Okay, so we have looked at this advantage of using name constant. Okay, this is the example we have looked at it. We have just looked at it. And we have looked at the name constants and its benefit. Now let's learn about the enum type. Enum can be used to declare multiple constants of type int, having sequential int value. So it is like a list of named constants. For example, here directions is an enum type, and there are 4 constants: the north, south, east, west. If programmers do not specify the numeric values to these constants, the consecutive values beginning with 0 will be assigned to them. So north is equal to 0, and south is equal to 1, and 2 for east, and 3 for west. So directions, this one, and the direction in below one is equivalent, exactly the same. And so having said that, what are the numeric values for weapon, equipment, and gems will be 10, and defense constants? I will give 30 seconds to think about this one. Just guess what numeric value will be assigned to weapon, equipment, and defense. Okay, so if you are familiar with C, I'm sure that you can figure out this. You can solve these questions. Let's learn this one. Run this code to see the actual value. Yeah, this is the one. So this was the questions. I will make the text more bigger so that you can see easily. Okay, so this was my question. What numeric value will be assigned to weapon, equipment, and defense? And we can print these constants like this. So let's compile this program and see what value are assigned to these constants. Okay, so weapon is assigned to 0, equipment is 1, gem is 10 because we assigned 10, and defense is 11. So this is because I just explained that if we do not specify the numeric value, the 0 will be assigned to the first constants, and the next constants will have a integer value greater than 1. So 0 will be assigned to weapon, and plus 1, the equipment will be assigned to 1. And because gem, we specify the numeric value, gem will be assigned to 10. And because defense is next to gem, we give a numeric value by plus 1 to gem, so it's 11. So that is the reason why defense is 11 here. Okay, so let's quickly go to the slides. So here so the answer, weapon is 0, equipment is 1, and defense is 11. And switch this enum is very handy in using a switch statement. So I will quickly show you how enum type can be used in switch statements. Switch. So very similar to previous enum type. We have 4 constants, but we did not declare the numeric value for gen. With gen 10, we do not assign 10 value to gen. So for this one, weapon will assign to, weapon is equal to 0, equipment will be 1, gen is 2, and defense will be 3, 0, 1, 2, 3. And so I will compile this one. It's much better to show when running the program. So here it prints this string and it waits for my inputs in these lines. So if I enter 1 is equal to equipment. So if I enter 1, it prints equipment. Because 1, my input will be stored in mode variables. And in switch, here the integer expression should become here. And based on the result of these expressions, it goes to the different cases. So for this example, because I entered 1, which is equipment, it goes to this case and prints equipment. And if I input 2, it prints gem because 2 will be stored in mode and goes to here. Because gem is here, it prints gem. So like this way, we can use enum in switch statements. By the way, zero is exactly the same as this one. So case weapon can be written as this one. So this will give same result. So if I enter 0, it prints weapon successfully here. So you can choose to either write constant name here or actual the literal integer constants type int. These two are equivalent. Normally, writing this way is much better. It's easy to understand the program. So we have a look at the enum type. Okay, from C++11, strong enum is introduced to avoid problem with conventional enums. To declare the strong enum, all you need to do is specify class keyword here, like this one. And to access the enum value, you specify enum name and followed by 2 colon and followed by the value. So days is a strong enum's name, and 2 colons and value is GUA. So like this, you can access the enum value. And strong enum does not act as an integer. So so let's just quickly go back to the previous slides, I just showed that weapon can be written as this way. You can do whether write weapon constants or literal constants one, but this is possible because we are using a conventional enum type. And this is, if we are using a strong enum like this is not possible. This will trigger the compiler error. So here, days D stores the this value, and whether variable W type whether enum, this is also strong enum because of the class keyword. It stores the this sun, and it's illegal to compare this variable with int value because strong enum does not act as an integer, so it cannot compare with int value, but it can compare with the constants value in the strong enum type. So this is the legal. Okay, this strong enums, because it does not act as an integer, which is very old because enum is not integer, but it can act as an integer. This is very old, and it will opens up the possibility of human error. So strong enum completely disables this by not acting as an integer. And the strong enum also solves the scope problem. I will explain about the scope problems in conventional enum using example. So enum 2 maybe. Okay, yes. Okay, just look at this example first. So this is a conventional enum because there's no class keyword. So conventional enum act as an integer. So weapon can be used for the arithmetic operations like this way. So if we print this X value, it will returns 10 because weapon is 0. Let's see. Results of running. Okay. Okay, so if I run it, X is 10. And let's say if I change to this one, the result should be 11 because now weapon is 1 and 1 plus 10 is 11, so X should be 11. If I compile again, print it. Now, as expected, X is 11. This is not possible if we change this to the strong enum type. Okay. As you can see here, it cannot find the you cannot find weapons. So as I explained in the previous slides, we have to give enum name here. we have to reference strong enum type like this way. So let's compile again. Okay, so it gives a lot of warning, but if you look at the arrow, so it does not allow us to add this strong enum constant with an int value. So in strong enum, it does not act as an int value. So it's not possible to doing this in strong enum. Compiler complains about it. And let me explain about the scope program. So in traditional enum type, the conventional enum type, this will give a compiler error because these two enum variable x and y has the same names of constants. Because these two enum, even these two enum has a different name x and y, they are sharing the same scope. So they cannot have the same name for their constants because they are globally scoped. But in the strong enum, like this one, so these two are strong enum type because the keyword class is specified here. This is legal statements, even though these two variable strong enum type has two constants with same name. This is illegal and completely fine. That is because these constants are scoped in this enum type, and these constants are scoped in this enum type. So as you can see here, if you want to access OK, these constants from this IO result strong enum type, you have to specify this enum name. So by doing this, we can figure out which OK we are referencing it, whether this one or this one. So if we run this one, let's run this one. Okay, so forgot to do this one. So compiles successfully without any warning or error. If I run it, it prints IO done. It's this one. It prints IO done because IO return code is equal to IO result OK. So this is equal to this. So it prints this one. And as I mentioned earlier, that because strong enum does not act as an integers, you cannot do this. So if we change code to this way, and if we compile again, it gives a compile error. The type int is not implicitly converged to IO result. So it cannot converge to the IO result. Cannot converge to the strong enum class. But this was possible in the conventional enum type. one, I think, in one, enum switch. So we have looked at this code before. So this conventional Enum type, with this conventional Enum type, we saw that this was possible. This should be 0 because weapon is 0. This was possible. This or case, both are possible in conventional Enum type, but in strong Enum type, this is not possible, and only this is possible. So that is the differences between conventional Enum and strong Enum type. Okay, let's go back to the slides. Okay, comments and style. There are two methods to insert comments in program. The 2/ indicates the start of the comments, and it is used for the comments with just one line. And the another method is / and star, and it is used for the multiple lines of comments. And there are 3 slashes, affects them as the 2/, but it usually indicates the meta informations. The doxygen, the automatic document generation uses this 3/. Anything between 2/, this one, and slash with star and star with slash, anything between these two characters, 2/ or /*, they are ignored by the compiler. So comments are usually used for explaining program with natural languages. So this is exactly the same as C, so I'm sure you have used this before, so this is not a difficult concept. And for program style, always try to make the program easy to read, modify, and maintain. There are naming conventions of identifier for making good program, such as constants should be all capital letters. This is not enforced by the C++ compiler. Even you do not follow these naming conventions, it does not cause any compiler error. But it is good practice to declare constants with all capital letters, so that even it appears in the middle of the program, we can immediately know that it is a constant. And similarly, variables start with lowercase letter. And as we talked about in the previous slides, in the identifier and variable slides, try to and always give a meaningful name to the variables.